For example 5, it says a sheet metal worker wants to know the arc length and area of a sector with a central angle of 150 degrees cut from a sheet of metal with a radius of 16.0 inches. So this circle here, we're only looking at that part of the circle that we're dealing with, the sheet metal worker's dealing with. He wants to know the arc length. All right, so up there, you can see I've highlighted that piece of the circle in red. That is the arc length. So when they're talking arc length, they're asking how far is it from point A, which is right here, around the circle over to point B. And let's call this center, let's call it circle P, just give it a name. All right, so arc length from A to B is how far is it, if I'm on the circle, walking around the circle, how far will I walk to get from A to B on the edge of the circle? The arc length formula is that, where D is the measure of the central angle and R is the radius of the circle. So those are the two numbers we need to know. If they happen to give you a radian measure, this is in degrees, but this is for degrees. If D is in radians, that's the arc length formula. I usually like D to be in radians, I prefer that, but if we have angle in degrees, we got to use the top one. So depending on how D is presented to us, we have to use the formula that makes sense for that value of D. So in the problem we're given a degree measure of 150, right? So D is given in degrees here, and the radius is in inches. So if I apply this formula here, this is the one I'm going to use right here because, again, I do not know the radian value, so this one down here doesn't count this time. And my D is equal to 150 degrees, my R is equal to 16.0 inches. The arc length in this specific figure is going to be 150 over 360 times 2 pi times 16.0. So I'm just going to get the formula written down. I'm going to substitute the values of the formula into the formula. Then I'm going to grab my calculator and I'm going to evaluate it. And keep in mind, just like all these other formulas have a divided by in them that we've seen, do the divided by last. So 150 times 2 times pi times 16.0 divide by 360 at the end. So when I type it in, 150 times 2 times pi times 16.0 divided by 360 comes out to 41.88790205. Now it doesn't specify any type of rounding. The fact they gave me 16.03 significant digits, 150 is 2 significant digits. Maybe they want 2 significant digits in the final answer. I'm just going to say let's round to a couple decimal places unless told otherwise. Let's just do that for now. So the arc length of this is going to be 41.89. The unit of length should match the unit of the radius. So if it's the radius is 16 inches, the unit of length on the arc length should be 41.89 inches. Because arc length is simply a distance. How far are you going? Okay, the second thing they asked me for, it says find the area of a sector. Area of a sector. And a sector is a piece of a circle like so. It's part of a circle, it's not a whole circle. Right? And the area of a sector is D over 360 times pi r squared, assuming D is in degrees. And it's 2dr squared, is that right? Hold on. dr squared over 2. dr squared over 2 if it's given in radians. So again, both these formulas have a degree formula and a radians formula. All right, So again, you have to diagnose how the angle is given to you, degrees or radians, to determine which formula to use. In this case, since we have 150 degrees, I'm going to have to use the degrees formula. So this is the formula I'm using this time for the area of the sector. And again, all I need is the angle measured 150 and the radius 16. So the arc length, the sector area of this one's going to be 150 divided by 360 times pi times the radius squared. So write the formula down, substitute the known values into the formula, and then use the calculator to evaluate. So I'm going to type in 150 times pi times 16 squared divided by 360. And that comes out to 335.10. The unit of length on the radius is inches. Area is always in square units, so this is going to be 335.10 inches squared. Just a quick note. I'm not really forcing you guys to memorize formulas here or anything, but just to show you where these formulas come from. 2 pi r is the distance around the circle, the circumference. So arc length's about circumference, it's about around the circle, but we're not going all the way around the circle, we're going part of the way around the circle. So there's 360 all the way around the circle, we're going 150 degrees of that. So that's why we're taking this fraction times the whole circumference. Pi r squared is the area of the whole circle, we're not going the whole circle and taking 150 360ths of the circle. So that's what these formulas are doing. On the radians, we're dividing by 2 pi instead of 360 because one time around the circle is 2 pi radians. If we divide 2 pi r by 2 pi, then the 2 pi's cancel, so the dr is what's left. And here, if I divide by 2 pi, the pi cancels the pi, so I get dr squared over 2. So that's all that's happening. So again, I'm going to supply these formulas for you on test, but again, as you're doing your homework, write the formula down. Substitute the known values into the formula, work the problem out, get me an answer, rounded to however they say, or a couple decimal places if they don't say.